The last section that we have to talk about for 1.2 is all about symmetry of your functions. This diagram is from your textbook, and I like the way it looks, so we put it on the slide. And we're going to talk about what type of symmetry your function has, but also what that means for whether it's even or odd. Now, the words even and odd, sometimes kids correlate that with what their exponents are. Like they assume every quadratic is even because it has an even degree. Well, that's not really true. That's not what even is going to mean. So we'll talk about what the even functions look like and how we can test for them in a second. Same thing with odd. So when you have different functions with different types of symmetry. Now this particular one here, this is not a function because it would clearly fail the vertical line test. But this is what we call a graph that has symmetry of the x-axis. So if we folded it along the x-axis, it would map onto itself. So what happens with your coordinate points, that every point xy has a corresponding point x negative y. So like if this is the ordered pair, I'm just making it up, like 4, 2, that means this would be the ordered pair 4, negative 2. And that's how you can determine symmetry, but most of you would determine symmetry just based on how it looks. So this is a type of function that has what we call y-axis symmetry. So if you folded it along the y-axis, you would see that it would be mirror images of each other. And the way those ordered pairs correlate to each other is that it has a negation for the x value. So like for instance, if this ordered pair right here was, I don't know, I should probably make something up, but let's just call it 1, 2. This would be the ordered pair negative 1, 2. We'll talk about the test in a minute. This guy here, this is called symmetry with the origin, or symmetry about the origin. That would be you folding it along the y-axis and then also the x-axis. So like you fold it hot dog style, hamburger style in the paper, okay? So that's called symmetry of the origin, and the way those points work out is the original point is called xy. He has a corresponding set of points, negative x, negative y. So there's like opposite twins on all of those ordered pairs. The algebraic test for this type of symmetry is where you replace y with negative y. That's a little confusing. We actually won't be using that test at all today. This one, however, we're going to use a lot. So we're going to be using the y-axis symmetry and the origin symmetry. We're going to use an algebraic test. What you're going to do is you're going to replace all your x's with negative x's. So you find out what f of negative x is, and then you compare it to, and this is kind of weird, negative f of x. So what that means is if you plug in negative x's into your function, oh, I'm sorry, that was totally the wrong thing. That's for the odd one. Erase. You just compare it to the original function f of x. So if you have symmetry of the y-axis, we're going to learn in a minute, that means we have an even function. If you plug in negative x into the function, you just get back your original function again. So that's the test that we're going to use today. However, if you have something that you think has symmetry of the origin, we're going to learn in a moment that's called an odd function. And what happens is when you plug in a negative x into your function, you get the opposite function back. Thank you. So we're going to see some examples of this in a moment. On your notes, you guys have this chart. So something that has symmetry with the x-axis, you're just going to draw yourself a little sketch of something with symmetry to the x-axis here. So it could be like a sideways parabola like this. It could be a sideways absolute value graph. And this is kind of confusing because it says what type of functions have this type of symmetry? Well, first of all, these are not functions. Why are these not functions? They're going to fail the vertical line test, so we can't technically call them functions. But if you're curious, these look like y equals x squared. Sorry, x equals y squared. And x equals the absolute value of y. Those are all different types of relations that end up with symmetry of the x-axis. We're actually not going to talk about that at all today. Here's what we're going to talk about. Things that have symmetry of the y-axis. So your friend, the generic parabola that's centered at the origin. That has symmetry of the y-axis. And we call functions that have symmetry of the y-axis even. So examples of an even function would be y equals x squared. Y equals x squared plus 4. Y equals x to the 6th power plus x squared. Now, I know you guys are looking at this going, well, there's a lot of things in common here, Bruzo. I notice a lot of even powers. We have to be careful about that. Just because it has even powers doesn't mean it's an even function. I'll show you what I mean by that in a moment. And then if you have an example of a graph that has symmetry of the origin, my favorite example would be the cubic function that's centered at the origin. These are referred to as odd functions. And some examples of odd functions would be like y equals x to the third power, or y equals x to the fifth power minus 6x to the third power. So again, I know you're looking at those going, those all have odd exponents. Like, what are you talking about? Again, we have to be careful about putting a Band-Aid over that and saying, like, everything with an odd exponent is an odd function, because that's not going to be the truth. All right, let's see this in action. This has already been graphed for you. This is the function right here. And just based on the looks, do you guys have any ideas as to whether, ignore the x-axis symmetry, do you feel like this has y-axis symmetry, or do you feel like it has origin symmetry, or are you feeling neither? Any first impressions? Origin? Feeling origin? Okay. Can we agree that it definitely does not have y-axis symmetry? There is absolutely no symmetry along the y-axis. So we're thinking it appears to have symmetry with the origin. But now we're going to have to test it out. And they've kind of already done this for you. So symmetry with the origin, another way to say that is that the function is odd. So here's how you do the odd test. And it's already done for you. I'm just going to write it again here. You take your function. You write the skeleton of it. But instead of an x, you're going to replace all the x's with negative x. So that's what they did right here. And now your job is to simplify that. So exponents go first. When you have negative x to the third power, this is going to end up being negative times x to the third power. But there's already a negative in front of it as well. So this entire term here is going to become a positive x to the third power. And then 2 times negative x will become a negative 2x. So here's the fun part. You have to compare this to this. Now clearly, guys, they are not the same. If they were the same, we would have said this was an even function. We already knew it was uneven. So then my next question is, if it's not the same, is it completely opposite? So go back and look at the original function. Do you have opposite signs on every single one of your terms, but everything else is the same? So since you have the opposite function, the function is odd. So that's the start of both tests. You plug in negative x into your original. You clean it up a little bit, and then you decide, do I have the original function back, or do I have the total opposite function? So let's see some examples here, guys. If you were to graph this on your calculator, which for the sake of time, maybe we'll skip it, but it does look something like this. So any first impressions? Even? Odd? Neither? Maybe odd? Okay. The odd exponent making you think it's odd? Well, here's the thing. It's fine to guess, but what we're going to do now is we're going to algebraically test it. So regardless of whether you think it's even or odd, the first thing you have to do is write your skeleton down and plug in a negative x. So now I need to clean that up. So negative x to the third power is going to be negative x to the third power, but then it's times a 4. So this becomes a negative 4x to the third power. And then there's no x term here, so this doesn't change. It's still a plus 1. So here's what I need from you guys. I need you to compare this guy to the original. Are they the same? No, so it can't be even. Are they the opposite? Oh, why are they not totally the opposite? What's the problem? Yes, this is still positive. So since that's not negative, they're not the opposite, so this does not equal negative f of x. So we just determined it's not even, it's not odd, so what do you think? It's neither. Very good. All right, same idea here, guys. Regardless of whether you think it's even or odd, you still have to test it out by writing the skeleton of your function. And then plugging in a negative x. So think about how this is going to simplify. When you have a negative x raised to an even power, what's going to happen with this term? It's going to be positive or negative? It's going to be a positive x to the fourth. Oops, wrong color. And then the negative x squared, when that's squared, it's going to be a positive x squared, but it already is multiplied by a negative 10, so it's still a negative 10 with a positive x squared attached to it. Plus 9 has not changed. So here's what I need from you. I need you to look at our new function, and I need you to compare it to the original function. They're exactly the same. So since this guy equals the original function, that means we are even. Very good. Oh, I've had a lot of trouble with this board today, guys. Come on, pen. All right, it's even. Oh, that's fun. Well, let's plug in our negative x. All right, so what's going to happen here is the negative x to the fourth power, that's going to become a positive 4. So you have 5 over x to the positive fourth power. Can you please compare that to your original? It's exactly the same. So since they equal each other, what do you have? Even. And you're like, I got the hang of this. I know she kept telling me the powers didn't matter, but everything that had an even power was even. But do you guys remember this one back here? This had an odd power on it for a degree, but it was neither. So maybe you've kind of figured out the trick here. There is a trick for you guys to anticipate whether it's even or odd, but by the time you go through that little mental calculation, you might as well just do the test. That's my opinion. All right. First opinion, you think it's even or odd? Maybe. I don't know. Let's test it. All right. Let's function skeleton, and we're going to plug in a negative x. All right. Let's clean it up. Negative x to the third power. What's going to be the sign on this first term? Negative. So negative x to the third. And then here you have a negative 6 times negative x, so that's a positive 6x. I need you to compare this new function to this original function. They're clearly not the same. Are they exact opposites? Yes, they are. So since this equals negative f of x, we are odd. There you go. Very good, very good. All right, so 10, based on the shape, do you guys have any opinions just based on the shape, even or odd? So even would fold along the y-axis, and odd is the symmetry one of the origin. I'm thinking this one's odd, but you know what? Let's go through the test anyways. So if we think it has symmetry with respect to the origin, we're going to do the odd test, which starts the same way as every other test. So you type your you write your function down, but instead of x, you're doing a negative x. Now guys, simplify that for me. Negative 2 over negative x would be a positive 2 over x. So please compare that to your original. It's clearly not the same. Are they exact opposites? Everyone thinks no. They are. Because what would happen if you took this function and you slapped a negative 1 in front of it? Because that's what opposites mean. This is just one term. So these are opposites. This is negative f of x. So is it odd? Yes, it is odd. Now, because it is odd, what type of symmetry does it? You got to connect these two ideas. If it's odd, it has symmetry of the origin. Now, 11's weird. First of all, this is a parabola, and this is a fifth power polynomial. Those don't match. So this is not the graph. Scribble that out. So let's pretend I didn't have a graph of it. I also can't think right now, so I can't even look at the graph. Let's just do the test. I know the test starts the same way. You write your skeleton, so negative 0.5, and then to the fifth power minus 3. And you're supposed to plug in a negative x into your function. All right, let's come up with the simplification. Negative x to the fifth power, is this term right here with the exponent, is it going to become positive or negative? So this is negative x, but then it's times a negative 0.5. So negative times negative, the final term will be positive 0.5 x to the fifth minus 3. Could you please compare this new function to the original function? Though they're not the same. Are they exact opposites? No, they are not. Who's the problem? This -3 did not change sign. So since that didn't change sign, this is neither. There's no symmetry on this graph. If you actually looked at it, it kind of looks like a cubic, but it's got more wiggles in it, and it's shifted like down 3 units, and it's reflected. It's weird. It has no symmetry is the point to that question. All right, so that was the end of the lesson. I'm going to stop the video. You guys have a pretty lengthy looking homework assignment, but it's going to go real fast. Your homework assignment is on your blue sheet. I don't think this is the correct homework assignment, so I'm going to ignore that slide. But you guys, it's yesterday and today. So domain and range, evaluating functions. I have a couple extra books flying around the room right now. Some people are just like taking pictures and then like holding their phone open while they're doing some book work. So I'm going to give you guys work time. Okay. If work time's not productive though, we'll stop and I'll just start the next lesson. But a word of warning, tomorrow's lesson, like bell to bell, information being thrown at you, okay?